Today I'll teach you how to implement this effect from scratch, using vanilla JavaScript and HTML canvas. I'm doing it because of popular demand from people on Reddit, but also because Halloween is coming soon, and I think it's kinda spooky. Let's begin. Oh, and I'm gonna be coding this at level 3. If you wanna know what that means, check out this video. But later, now it's time to do some coding. We begin with basic HTML. A head section where we're gonna input our scripts, and our body section, which is just going to contain a canvas element with ID myCanvas. This is gonna be a canvas application. Now, in the head, I'm going to link to my style sheets. And this is an empty file for now. And also to the JavaScript code. Like that. And I'm going to give a title to this document. Let's call it Torch Camera Effect. All right, I'm going to save this and refresh, and nothing happens so far. I'm just changing the name of the tab there on the top. But let's style this a little bit. I'm going to add a style for the body. And I'm going to set the background to black and remove the margin. And this is now going to change the background. And the canvas, which we added already, let's make its background to white. Otherwise, it's just transparent there. So now you can see it in the top left. But I want it centered, so let's position absolute, and then top 50%, left 50%. And this is going to put the top left corner of the canvas to the center screen. We actually want to translate it back by half its width and height, so we do transform translate minus 50%. Minus 50%. And now we have everything just about right. Let me just set the width of 100% so that now our canvas stretches over the entire screen. It's going to be the main focus anyway. So now let's go and work with the JavaScript code. I'm going to write here unload a JavaScript function called main. I'm going to call it, and define JavaScript code in script.js. So our main function is going to get a reference to the canvas by document get element by ID myCanvas. And I'm going to also get the reference to the context. So the 2D context of the canvas element will provide us all the methods that we need to do the drawing of this effect. And these are going to be globals. Like that. Next, we're going to access the camera. So we're going to ask the navigator media devices to get user media. And we're going to specify here that we want video. Now this returns a promise, so we're going to say then, and give a callback function here with an argument that has the raw data coming from the camera. Now with this raw data, we can actually give it to a video element. So first I'll create it like this. Document create element video, and I'm going to set its source object equal to this raw data and play. Now, it's gonna take a while until the video starts playing, just a few milliseconds. But when it's ready to do that, it's going to trigger this video on loaded data. And we're gonna pass here a callback function. Let's say animate torch effect. And this function is something that we will work on next. But before that, let's put here the video as a global as well. We'll need access to it later, and add also a catch here, because it's possible that somebody is not going to allow the camera or something will malfunction and we need to warn the user. So on error, we are going to just alert this error. All right. Now inside the animate torch effect, let's begin by setting the canvas width to the video width. And we are going to do the same for the height. And we're going to draw the video image on top of the canvas. And now it's just going to fit perfectly. So we can do context, draw image, and we're going to pass the video. And we're going to start the drawing at 0, 0, so the top left corner, and use the canvas width and canvas height for the sizes. And we need this to animate as fast as possible on every frame. And then the video is going to be displayed on the canvas live. So we do that by calling request animation frame and passing here this same function that we defined earlier. In that way, this is going to recursively call the function again and again, and it's going to try to do it 60 times per second. So if we go now to our code and refresh, okay, it works. I have another camera there. So now everything works and we have the video showing on the canvas. We can begin to do the image processing. And that's going to happen here, and it's going to be where all the magic is going to happen. So the first thing we need to do is find these blue pixels somehow in the image. To do that, we're going to call the getImageData method. And we're going to get it for the entire canvas. So it's going to start at 0, 0 and have a canvas width and canvas height. And let's store this in a constant. And to really understand how this object looks like, I'm going to log it in the console. And let me just cancel this request animation frame for the moment. Otherwise, my console is going to be flooded with a lot of image data, and there are a lot of pixels, so it might even crash my browser. So let's see. All right, a still image of me there. But now we can see here the image data printed in the console. And the color space is standard RGB, so that should be familiar. And the image width and height are here, but also this very long array, like 1 million something elements. And this is actually 480 times 640 times 4, because this is a very, very long one-dimensional array where the pixel values are presented as groups of 4. So this is now the red, this is the green, this is the blue, and this is the opacity or transparency of the first pixel here in the top left corner. So this information is just for one pixel there. And this opacity is actually 255 for every pixel because this image is fully visible. It doesn't have any transparent parts. So what we are going to do now is try to figure out what is the color of this marker. And I'm going to print this top left pixel only and see if we can get the color by moving the marker in that location. So let's try here and print something like a RGB string here, where the first element is going to be image data dot data of 0 and then comma, and let's put here 1 and 2 as well. And this line is quite long. We can actually do object destructuring here and work only with the data of the image data object. So this is going to make a little less code in the next line. And let's remember here 1 and 2. So now I'm printing the red, green, and blue color components of the image data of the top left pixel in the image. I'm going to save this and refresh. And I actually want to reactivate request animation frame because I want to be able to do this. So you can see the numbers there being printed in the console. They are kind of close to 200 each of them. That just means that this is a grayish color in the background on the wall. But if I put the blue marker there, you can see that they change. So now it's showing some blue color. And let me just scroll up here in the console. And yeah, so this blue color is changing all the time because this marker is not exactly blue everywhere, and there are lighting effects here, and there is noise in the camera and so on. But I'm just gonna keep one of these elements here for reference. So this is gonna be the color that we are looking for. And I'm just gonna store this in an array. And we don't need now this console log here anymore. So next we're gonna loop through all the pixels and try to find those that match this color. And we're gonna do I starting at 0 and to the length of this data. And we are actually gonna jump 4 elements at the time because we want to work with pixels, not individual color components. So we do this. And now we can say that red is equal to the data of I, green is equal to the data of I plus 1, and blue is equal to the data of I plus 2, and the alpha is equal to data of I plus 3, but we are actually not going to use this, so it's just there so you know it exists. But now we have these red, green, blue values for each pixel, starting in the top left corner and going row by row until the end of the image. So what we do with this now is check if this value, if RGB, is equal to the color of this marker that we somehow marked there earlier. But the problem is that this is not going to work because I'm trying to match here the colors exactly, and what I actually want is some kind of approximate match. So if you want to understand what I'm doing next, you might want to watch my video on color spaces. But basically we are in a 3D space where red, green, and blue are the axes. And we want to calculate the distance between the color that we are seeing and that we have in memory. So let's write here distance between whatever the pixel says and this color. And if this distance is less than a threshold, say 50, then we have found one pixel that matches this color. And our distance function is just the distance in Euclidean space between two vectors. And this is essentially the length of a diagonal of a cuboid. So it looks something like this. It's essentially using the Pythagorean theorem twice to get this formula. I might add some kind of animation of how to do this somewhere on the screen now. But if not, do watch the Pythagorean theorem video that I made some time ago. At least if you're not familiar with that, then you should be. And also try to think how this is applied twice to get the diagonal of a cuboid. It's not really that complicated. Okay, so now we have here a square root, right? And if this distance is less than a threshold, then this pixel is worth to consider. And what you want to know now is the location of this pixel. So let's store the location of all these pixels that are gonna match in an array and say locations is equal to an empty array here. And let's see what is the X location on the screen of this element. So knowing its I value here, and because we jump in groups of 4, we can say I divided by 4, and this is going to give the pixel index. But because this is a one-dimensional array, at some point it goes past the width. So if we want to know how much from the left side of the screen this goes, we need to say modulo canvas width here. And for the height, we do something similar. Again, we want to know the pixel index in this very long array, and then we divide by the width and learn which row this is. And because this doesn't divide perfectly, we need to use a floor function here. So now we're going to store this X and Y in the locations array like this. And to test, let's see how many of these good pixels are in the screen. So I'm gonna console log logs and refresh this page. And okay, maybe I want to print logs.length here. So now it says there's 0, but if I'm gonna bring my marker on screen, you're really gonna see that number spike. So let's put it just a little bit in the screen, and you see only few pixels, like less than 100. But then as this is going inside the screen, a lot of these blue pixels are appearing there. So we are figuring out how much blue is in the image like this. To get a better understanding, let's try displaying these locations somehow. So I'm gonna cancel this for now and say let's draw on top of the pixels. So we're gonna do context, fill style, set this to green, and then begin path, and use the arc method and draw a small 1 pixel circle there at the location of i.x and location of i.y, 1 pixel radius, and a full circle starting at 0 radians and math.pi times 2 radians, and fill. So now I'm expecting to see the pixels that we are identifying turning green, and they do, kind of. Sometimes not all of them turn green, but you can adjust if you want this threshold here from 50 to something bigger if this doesn't happen with 50. But yeah, now it's more of the blue pixels are turning into green. But we don't necessarily need this to be perfect. So any value here, like 50, will work. As long as it finds some blue there, then it's enough. And let's put this as a threshold so that when I share the code with you later, you can easily play with this. Like that. And finally, here we don't actually need this code anymore. I'm gonna remove it and try to find the center of mass of the blue object that I'm bringing in the screen. So if we have blue pixels to work with, we are gonna say that the center initially 0, 0, update this based on all of the locations. So this is the average on X and the average on Y. And we're gonna loop. And add each of these elements, and then at the end we are just going to divide the result here by the length of this array. And now we're going to have the X and Y of the center point. And let's actually display this center point, so using the same thing from before. But now we're gonna draw the center. And let's give it a 50 pixel radius, again starting at 0 radians and math.pi times 2. Oh, an error. My center needs to be here. I was outside of the scope. Okay, so now we get this nice circle there where most of the blue is gonna exist in the marker. Notice that it's not totally perfect, because if this bottom side blue appears there, the point kind of moves in between the two blue areas, but this is just fine for this effect, and you can get a better marker if you really want. So next what we want to do is actually style this this green circle in a different way to make it look like our effect. So I'm going to use a radial gradient here. And the gradient is going to start at the center X, center Y with a radius of 0, and end at center X, center Y with a radius of, let's use this 50 value that we had below, and add the color stop at 0 and set this to RGBA, so also opacity here, starting with fully transparent black and then semi-transparent black, quite close to black at the end, and replace here the fill style to this gradient instead. I'm going to refresh and you can see how it looks like now. Basically, the middle of the marker is fully transparent, but then it goes and makes a circle with the black on the edges. So we want to have this circle fill the screen actually. And we need to know what radius to use so that we won't have any region left without this transparent blackness, if you will. So in the worst case, our marker is going to be in some corner, and then we need to know the length of this diagonal here. So we use Pythagorean theorem again and find out what this radius is. So radius is equal to square root of canvas width times canvas width plus canvas height times canvas height. So this is the length of our diagonal, and replace here 50 with the radius that we have just calculated and refresh. And now we get an interesting effect, but it's not exactly that one that I showed in the beginning. So to get that one, you have to play with these radii here in the radial gradient function. So for example, if you make here the radius, not the full radius where the black is 0.8, but maybe you say that at 10% of the radius this already starts to happen, then this is what you get. Maybe I'm gonna increase this to 0.2 here. Okay, it looks a bit more like it, doesn't it? So I also did here I used the radius with some kind of very small value, and that made it so that here we have a little bit of fully transparent region where the marker is. And one last thing that we need to do, actually two more things. First, when this marker is out of the screen, everything should be dark. So now everything is bright. This doesn't make sense. So I'm going to go here and say that else. So if we don't have blue pixels, then I'm going to say context fill style is equal to RGBA 00000.8, so basically the transparent black, and draw a rectangle all over the screen. So context rect from 0, 0 to canvas width and canvas height, and CTX fill. And this is gonna do justice here. So now I'm in the dark, but when this comes in, I start to see the light. And second thing that I like to add is this kind of flickering of the light. So now everything just looks too much like a flashlight, maybe. Yeah, some people on Reddit called this a flashlight. So let me modify this radius here a little bit and add a little bit of flickering. So I'm gonna use let here and say that I want to add to the radius a random value between 0 and 10% of the radius. Yeah, so now when I refresh, my radius just gets a little bit bigger and smaller all the time, but just a little bit. You really don't want to overdo this. So now it kind of looks like something is flickering there. And that's pretty much it. So this is actually a simpler variant than what I posted on Reddit. It only works with one marker. The one there works with more of them as well. But let me know if you're interested in these kind of things, and maybe I'll show you the more complex variant as well. Or somebody was talking about lightsabers. That could be cool. Anyway, happy Halloween and see you guys.